So as we look a little bit closer at the node, as the force comes down into the bottle-shaped strut and then comes back into the node, we have the tensile forces developing. So for our force of 1,000 kilonewtons, we have the strut force, which equals, right, F equals 1,000 on sine 40, so the angle theta to the strut. It's 1,560 kilonewtons. So that's coming down here, so that's coming out and back in. So for this force here to develop, we have alpha. So if you look at 7.2.4, so we're gonna, for this example, look at it for strength. That's 10, alpha equals 1 on 5. Therefore, alpha is 11 degrees. So if that force here is 1560 coming in. That force equals 1560. Then we have, to get this force here, we have sine 11 equals x on 1560. Sine 11 times 1560, 300 kilonewtons. So we'll say the tensile force here developed is 300 kilonewtons that we have to account for. So now we're going to look at the bursting force across the strut for cracking. So this is just looking at the tensile strength of the concrete. So the bursting force across the strut, so the bursting, say, capacity of the concrete will be found in 7.2.4, so TB equals 0.7 times the width of the strut times the length of the bursting zone. So that can be found in figure 7.2.4a. So for our example, it'll be the length from here to here. And if you look at 7.4.a, you minus the depth of the strut on 4 at each end. So we're going to say our length is roughly 4.5 meters times the tensile strength of concrete. So for us, our width of the strut is 200, which is the thickness of the wall. The length of the bursting zone, you say 4,500, 4.5 meters. Dash CT equals 0.36, the tensile strength of concrete, times the square root of F-C, which is 65 MPa, which equals 5 times 0.36, 2.9 MPa. So that means our bursting capacity is 0.7 times 200 times 4,500 times 2.9 equals 1,827 kilonewtons. So if you look at the next section, You need to find out if the calculated bursting force, which is 300 kilonewtons, if it's greater than 50% of this, which is 913 kilonewtons, then there are extra checks or extra requirements for your reinforcement to be designed for.